We discovered or rediscovered in the previous video that C-cast would allow us to convert types to other types, and that we needed to rearrange the bits to make them match the new type. But there is another particular type of conversion which is very interesting, in which we have an identity cast. What I mean is that the base value keeps the same bits after conversion in the same order, so there is no actual conversion during the cast. This particular type of conversion, the identity conversion, is called a reinterpretation. Reinterpretation is a second cast effect, which we'll discover together in this video. For that, here is a little example. We'll work with an A variable of a float type, having a value 420.042. For example, this value will be our reference value. We'll manipulate this value using addresses to highlight the notion of reinterpretation. I told you in the previous video that there is a hierarchy between types. Some types were more accurate than others, and we had some restrictions to go from one to the other. Of course, with address types, we will have the same type of hierarchy. A particularly interesting address type, the void type, will allow us to store an address of any type. From there, we can say the void type is more generic than all the other address types. For example, the address of a float, which is a more accurate type than the void one. So we have again this notion of hierarchy. And we'll find the same implications as in the case of a conversion for a reinterpretation. We can see on this line the case of a reinterpretation of the address of a float as a void. Here we have an implicit reinterpretation. Since, as you can see, I haven't put anything between the equals and the ampersand. On the following line, we have the same interpretation, but with the explicit cast this time. I'm using the syntax with parentheses with the type to which I want to cast. So here we are reinterpreting the address of a float as an address on anything. We lost in accuracy but gained in genericity. Of course, we'll have the same notions of hierarchy we learned with the conversions, which means that in a case of promotion, moving from a more accurate address to a more generic one, it'll be possible to make implicit promotion. There's no problem since we are moving to a more generic type. However, the question is, what happens if I want to do the opposite? I mean, here I have my D variable, which is of the address on anything type, a void star, therefore a more generic type, and I would like to cast it. Reinterpret it as an int star type. What happens here? We can see that I'm doing a demotion, meaning gaining precision with my types, using an int star type. But remember, here I have the D variable, which is one of the address on anything type. And I was taking in particular the address of the A variable, which is itself of the float type. Here I want to reinterpret this address of float as an address of an integer. That's when the demotion, returning to a more accurate address type, can cause a real problem. In this case of implicit reinterpretation, I will just convert the address of a float into the address of an integer. And we saw in the previous video that the way the bits of integers, floats and doubles are encoded differ drastically. We'll find out that it will have a very annoying effect. However, if I actually want to have this reinterpretation, in the present case the example is stupid. But we could imagine hiding data in the structure. Make an explicit reinterpretation thanks to the syntax with brackets. In the case of an address demotion, therefore a descending reinterpretation, we'll always privilege the explicit syntax to tell the compiler and the future developer who will use your code that the demotion was made on purpose and wasn't a programming mistake. To highlight all these behaviors, I wrote a few lines below. Which will allow us to output exact values. First, we'll output the address of our float, as well as its value. Then I'll output the address values of my void star. So we'll see that it's indeed the same address as the one on the float, and right below, I'll output the result of these three last lines, and more particularly, what we are actually interested in, these two lines, which will allow us to see that our float has been reinterpreted as an integer, with the consequences you can imagine. Let's make a little compilation to be sure of this. Here, let's run it, so we can see that the address of our float was a random address on the stack, and the value was the one I gave it. By the way, we also see that the precision of the floats makes it impossible to represent exactly 420.042, but 0.041922 instead, which is the closest representable value in a float. Anyway, we can see that once I make my reinterpretation in a more generic type, we have no address issue. Since this is an identity cast, it is a reinterpretation, the address is the same. Then here I see the two lines we are interested in. The one on which I reinterpret my void star, which is actually a float address, as an integer address. I mean that at the end, I'll be able to unreference my integer address to get the series of bits at the end, which is actually a float, but have it as an integer this time. Here we can see that when we take the bits of the floating value 420.041922 and reinterpret them directly without conversion as an integer value, we get an aberrant integer value, which has absolutely nothing to do with the original floating value. The point of all this is that we still have the notion of hierarchy through the address types. The void star type will be more generic than all the address types. Since we want accurate types, it will be possible to do promotions from an accurate type to a less accurate one, namely the void star, and an explicit or implicit one, since it works in this case, but we're losing accuracy. However, if you wish to regain accuracy, you'd have to be very careful with the type we choose to reinterpret your address in. Here we can see that interpreting a float address as an integer address is clearly a programming mistake, since the final value is totally different. However, it's a behavior you might want. I spoke briefly about structures earlier. We can imagine manipulating different structures, having more or less identical fields using a void star generic pointer. Then reinterpret them with the good values to do more advanced things in C. It's totally possible, and it's even used sometimes. But that's the principle we are highlighting, and in this case, you should never the implicit syntax, since you won't be able to tell the difference between what you actually want to do and a programming mistake. So since it's for the conversion, in the reinterpretation, you should always, in the case of descending reinterpretation, use the explicit syntax to tell either the compiler or the user that you actually want to make this reinterpretation and potentially have a strange behavior. What I just showed with the reinterpretation is something we'll see again in a moment in the next videos. Keep in mind that with the classes, we'll have similar behaviors, although they are a little different in C++, but they work the same way. So it's important to understand that a cast can be an identity cast, meaning that the bits aren't reorganized, and this identity cast is a reinterpretation, and will allow this address tweaks with pointers, and to be able to switch to more generic or more accurate addresses with the related behaviors. That's it. I'll see you in a moment for the next part of this video series on C casts. See you.